Okay, hi y'all. My name is Charles Whitfield, and this is my technical blog post number 5 for DBC's Phase 0. For whatever reason, I didn't really feel like doing a full text-based blog post for this one. I wanted to try video, so we'll see how it goes. The learning competencies for this blog prompt are explain when, why, and how to use classes, and explain how data structures and classes can model a real-world object. So when, why, and how to use classes. Classes are useful when we want to have multiple different objects with shared methods but different specific attributes. So for example, the string is a class we're all familiar with. This class allows us, let's see, here's its class string here. And this class allows us to use methods like length without having to rewrite the method every time we want to use it. So we can have dog, the length of the string dog, and the length of the string bloodhound without having to rewrite what method is every time. So this is convenient, obviously. But we can also make our own classes with our own methods. And sometimes we can use those to create data structures that model a real-world object. So the most straightforward example of this is probably using multi-dimensional arrays to create a grid that we can then use to represent a grid that actually exists somewhere, like maybe a tic-tac-toe board on a piece of paper. So that's what we're going to do. We're going to create a class that allows us to play games of tic-tac-toe. So first, obviously, we'll want to name the class. We'll name it tic-tac. And we need to initialize this class with an initialize func method. So all tic-tac-toe boards start out the same. So we'll have at board, this instance variable. All tic-tac-toe games will have a board. And it'll be an array .new. And we want to fill it with 3 other arrays that all are filled themselves with these strings of just one blank. Okay, so this is great, but we can't see it. It doesn't do anything. So we want to have a method to show us the board. And we'll do that, define show board. And then we'll just print each row of the board. And I guess we'll have driver code down at the bottom here. So for our driver code, we'll have game1 is equal to tic-tac.new, and we'll call game1.showBoard. So we can see here that we have a grid of 3 by 3 blank spaces to play our tic-tac-toe game in. So what's next from tic-tac-toe? We need to choose whether we're going to be X's or O's. So we'll define choose letter. And here we need to take some input, because if you don't choose a letter, by choosing a letter, by inputting a letter, and what are we going to do? So we'll have a new instance variable called player, which will be equal to the input. And if the input is string x, we'll put you are player x. And we'll set the computer's player variable to equal the string O. Else, if input equals O, put you are player O. Come on, okay, player O, and we'll set comp to the string x. And then if the input's not x or O, we're not really playing tic-tac-toe. Can't have a game of tic-tac-toe without x's and o's, so we'll raise an argument error. That, and end the method. So let's go back to our driver code and try aim1 dot choose letter, and we'll be x's this time. Whoop. Expecting end of input. What do we got here? We got too many ends. I over-ended myself. Okay, so here, you are player X, great. But we can't play just by being player X. We have to define a way to move. So we'll define move with two arguments, the row address, or the row coordinate, and the column coordinate. And these have to be numbers, obviously. So we'll say at board, we can't move on let's see, here we go. So row -1, so that we don't have to input 0, 1, 2, or 3, or 0, 1, or 2. We can input 1, 2, 3, like normal people would, and then it'll be able to interpret that. But we can't move on a blank or on a non-blank space. If we already have an X or an O there, obviously you can't. That's not a playable space. So we'll set the condition here. If it's blank, then the coordinate, if the guess coordinate is blank, then the guess coordinate will be set to string X. But if it's not, then it's set to not the string X, but the variable, instance variable for the player's chosen character, which could be either 1, X, or O. But if it's not the case, then we will raise an argument error because you can't move on a space that's already occupied. Then we'll display the move. So here's your move. And then we will execute the method show board. And let's see. So let's try that with aim1 dot move for maybe the center. It's kind of a boring move, but we'll give it a shot anyway. Oh, nil. Okay, what's going on here? Nil. We didn't input our choose letter, so we can't have that without that. Here we go. There we go. Your player X. Here's your move. X right in the middle. Okay, we can also move this to 1, 2. Move it up to the top, or we can move it to 1, 1. Move it over to the left corner. Okay. So that works, but let's have the computer move as well, because you can't just play against yourself. You'll just fill the whole board up with X's. So puts, here's my move. Because as we write this, we are the computer. So we'll have the computer's row coordinates be anywhere from 0 to 2, and then set that to an array and take a sample, a random number from that range 0 to 2. And we'll have the computer's column equal to the same. So it will select a random row and column from 0 to 2, which remember are the coordinates for boxes 1 to 3. And then say that that is the computer's move. Or board these coordinates comp row and what if the computer doesn't pick randomly a blank space? So we can't have that. So until computer's move equals a blank space, we want to redo the sample. So we'll just take this here. And replace it there. And so that'll keep taking random samples until it finds a coordinate that is a blank space. And then we will set board coordinates for the computer move equal to the computer's symbol. At first, when I did this, I set symbol here equal to computer move, but that just redirects the arrow that points computer move here. So rather than having this affect this, it only moves this from pointing to this to the board coordinates. Now comp move points to just the O or the X as the case may be, which is no good. So we need to set the board coordinates equal to the computer's symbol if we want to replace that blank with the computer symbol. So it should work now. If we choose a move, then the computer will also choose a move. And we want to show board as well for the computer's move. So let's try this. Okay, so we chose a move. We chose the top corner, and then O chose, the computer chose right next to us. So we can do multiple moves. Game1.move, maybe 3, 1. And game1.move, maybe 2, 2. So if we choose this and then the computer randomly selects to move there before our move gets executed, then it'll raise an argument error. But otherwise, it should work. Yeah, wait a minute here. 3.1. Gotta patrol those typos better. Okay, here we go. So we've played out. Here's your move. Here's my move. And we got an argument error for, which move was it? I guess for our third move. Yeah. But anyway, we can do 2 moves here. And then the computer will also do 2 moves. And we're not going to bother setting conditions for winning right now because that's not really the point of this exercise. But you can see how this grid, this multi-dimensional array grid, these arrays inside arrays can be used to model an actual tic-tac-toe